Hi, and welcome to this tutorial. This one's about how atoms bond. So basically, in a word, how a compound is formed. So it's either done by transferring or sharing electrons. So, which of the numbers in the diagram below indicates the orbit of electrons that could bond with electrons of other atoms to make molecules? Okay, number 4, Roman numeral 4, is pointing to protons. And it's never going to bond with protons. Protons are never involved in bonding. So that's a no. So that one's wrong. 3 is pointing to some inner shell electrons. You can't really see the line, but there's the line. So that would be like first level, and that's not going to be the case. Then they're pointing to the second level, and that's not going to happen. They're always going to bond with a valence or outer shell electrons. Okay. Which of the following is true about electrons of atoms that bond to form molecules? A, they're the strongest electron in the atom. B, they're the largest electrons in the atom. Guys, electrons are generally the same size. Okay? And electrons are the same charges. They occupy the outermost orbit of the atom. Which electrons bond? Valence electrons, the outermost electrons. This is probably the correct answer, so let's go ahead and circle it, but let's read D to verify. They are electrons closest to the nucleus. Nope, they're not going to be involved in bonding. Lithium releases an electron to fluorine to form the compound lithium fluoride. Analyze the model of this ionic bond. And again, guys, just so you know, an ionic is a metal bonded to a nonmetal. Okay? Shown in the diagram below. Which of the above electrons transfers correctly models the bonding arrangement between lithium and fluorine? Well, the lithium is a metal, so it's going to donate the electron, and fluorine is going to receive it. Okay? So, N1 is showing the electron transferring from lithium, which is good. So that's good so far. So 1 looks okay. 2 is showing the electron transferring. Oh, what you guys are not seeing here is this is an inner and 3 is an inner. And the only one that's outer, a little bit hard to see, is 2. So they're both pointing to, 1 and 3 are pointing to inner electrons and 2 is pointing to an outer electron. Okay, remember what we learned from the previous slide? Only outer shell electrons are involved in bonding. So 2 only is the correct answer. And I apologize, but even on my copy on my desk, it's hard to read. Okay, and 2 is the only one where it's pointing where it's going to the right level too. Well, 3 is, but 1 is way off. So helps a little bit. Atoms bond with each other by transferring or sharing electrons. Sharing electrons is covalent bonding. Transferring is ionic. Okay. Identify the model above that shows the correct bonding arrangement of electrons between 2 hydrogen atoms to make H2. Well, when it's 2 alike that are nonmetals, which hydrogen's a nonmetal, it's going to be a covalent bond, and they're going to share electrons. Okay. So think for a minute and think about it. Okay. In Model 1, it's not showing they're sharing, so that's what makes Model 1 wrong. Model 3, they're bonding the protons. That's what makes Model 3 and 4 wrong. Correct answer is Model 2. Observe the picture of sodium releasing electrons to chlorine to form sodium chloride. So first off, so what type of elements are these? That's the first thing you should do. So that's a metal. This is a nonmetal. The only type of bonding that occurs is between a metal and a nonmetal is an ionic bond. Okay? An ionic bond. So, should make the answer really clear now, right? Which type of bond is formed by sodium and chlorine to form sodium chloride? It's an ionic bond. It can't be covalent. There'd be 2 nonmetals. Nuclear bond, no. And atomic bond, no. Okay? Which type of electron bond is formed when atoms share electron? Well, it's a covalent bond because they coexist, they cohabitate, and when you you share. Okay. Which of the following statements is true about ionic and covalent bond? Well, let's review in our heads quickly what we know. I know that an ionic bond is between a metal and a nonmetal, and a covalent bond is between nonmetals. Okay? So A says ionic bonds are formed between nonmetals. Wait a minute, that's wrong because we just said ionic bonds are formed between metal and a nonmetal. Okay? Ionic and covalents can be formed between metals and between nonmetals. That's not right. There's a different type. Covalents are just nonmetals bonded to nonmetals, and ionics are nonmetal bonded to a metal. So ionic bonds form between metals and nonmetals. That's good. That's 100%. And covalent bonds form between nonmetals. That's right. Let's see. Double check. D says ionic bonds and covalent bonds always contain at least one metal and one nonmetal. That's not true. Okay, observe the diagram between ionic and covalent bonding. Which of the following is true about the models above? A, model 1 shows ionic because the valence electrons are shared. Wait a minute, does ionic bonding involve the sharing of electrons or the transferring? Ionic is the transfer. So this one is wrong because it's saying that they're shared, and that's not true. Model 2 shows covalent bonding because valence electrons are transferred. Wait a minute, what's the definition of a covalent bond? They're sharing electrons. So it can't be the model B. Model 1 shows covalent bonding because valence electrons are transferred. No, because in covalent bonding, electrons are shared. So model 2 shows ionic bonding because one electron is transferred to the another atom. That's the correct answer. That's what model 2 is, and that's also the definition of ionic bonding. Analyze the periodic table to answer the question. Which of the following is an example of an alkali metal forming an ionic bond with a nonmetal? So an alkali metal is right here, family number 1. Okay. Nonmetals would be anything right around here. Okay. Potassium can form an ionic bond with chlorine. Is potassium an alkali metal? Yes, it is. Is chlorine a nonmetal? Yes. So A is probably our choice, but let's double check. Potassium can form ionic bonds with sodium. Potassium and sodium in the same family, so it cannot be an ionic bond. Oxygen can form ionic bonds with carbon. They're both nonmetals. They would form a covalent bond, so that one's wrong. Sodium can form an ionic bond with helium. Well, that may look to be the correct answer because it is an alkali metal bonded with a nonmetal. What's wrong is that helium would not bond. It's a noble gas, and noble gases don't bond. So the correct answer is A. Potassium can form an ionic bond with chlorine. Why? Potassium is an alkali metal, which is what we are looking for, and chlorine is a nonmetal that's able to bond. Analyze the periodic table and answer the questions. Metals can form ionic bonds with nonmetals. Nonmetals can form covalent bonds with each other. Identify the true statement below. So what this question is asking you is, how well do you know your ionic, your metals, and your nonmetals? Sodium is a metal. Fluorine is a nonmetal. What kind of bond would that form? Not a covalent, but an ionic. So that one's wrong. Magnesium can form an ionic metal bond with chlorine. That's true, because this is a metal, and that's a nonmetal. Okay. Lithium can form an ionic bond with sodium. That's wrong, because they're both metals. That would be a metal, but a metallic bond, and those two wouldn't even bond together. Potassium can form a covalent bond with calcium. Potassium's a metal. Calcium is a metal. They're not going to bond. That would do metallic bonding. So the correct answer is B. Why is that correct? Because magnesium is a metal, and we're asking it to form an ionic bond, donate electrons to chlorine, which is a nonmetal. Organic compounds are molecular compounds that always contain carbon, usually hydrogen, and often nitrogen, sulfur, and phosphorus. Identify the organic compound below. Okay, it always contains carbon. So does A have carbon? NH3. Nope, it doesn't. Does phosphate, P12A4, have carbon? No, it doesn't. Methane has carbon? Possible choice. Sulfur dioxide, no carbon, no C. So the correct answer is methane. Analyze the periodic table and answer the question. Okay, identify the true statement below. At transition, metals usually form bonds with noble gases. Again, guys, do noble gases usually bond? The answer is no. Alkaline earth metals can form bonds with each other. No, they don't. They usually like to form with other things. Okay? Nonmetals cannot form bonds with each other. Yes, they can. That's covalent bonding. Alkaline metals can form bonds with halogens. That's true. They actually do like to bond with each other because these guys like to donate one electron, while these guys need to receive one electron. Okay. Covalent bonds are formed when atoms share pairs of valence electrons. Ionic bonds are formed when oppositely charged ions attract. Ions are charged atoms or molecules. Analyze the following table showing covalent and ionic bonds. The elements potassium and fluorine can bond with each other, and the elements oxygen and sulfur can bond with each other. So, potassium and fluorine, this is a metal, and this is a non-metal. So what kind of bond is that? That equals an ionic. Okay, oxygen is a nonmetal, sulfur is a nonmetal. That is a covalent bond. So now we know we're talking about an ionic, and it's potassium and fluorine that are going to form the ionic, and oxygen and sulfur that are going to form the covalent. So the first one says potassium and fluorine, K and F, will form ionic bonds, and oxygen and sulfur will form covalent bonds. That's what they're going to do. Okay, so the rest are all wrong because they can bond together. K and F, they're always going to be ionic because the metal donates the electron to the nonmetal. And K and F will form covalent bonds. Nope, not going to happen. They're going to form a ionic bond. Analyze the periodic table below and answer the question. A sodium ion can form an ionic bond with chlorine. Okay. A carbon atom can form a covalent bond with an oxygen atom. Identify the true statement. Okay, carbon is a nonmetal, oxygen is a nonmetal. It is a covalent bond, right? So, carbon and oxygen can ionize to form an ionic bond. No, that's not true. They're going to form a covalent. Oxygen and chlorine can ionize and form an ionic bond. They're not going to do that, okay, because those are two nonmetals. Lithium and chlorine can form a covalent. No, lithium's a metal, chlorine is a nonmetal. They're going to form an ionic. Lithium and chlorine can ionize and form an ionic bond. That's true. That's exactly why it can happen. And why is that true? Because lithium is a metal, and chlorine is a nonmetal. And nonmetal plus a metal, they form an ionic bond. Thanks, guys. I hope this short tutorial helps you better understand, and keep studying.